आई एम सॉरी गाइस, एक्चुअली वो डिस्कनेक्ट हो गया था. ओके, टेक्नोलॉजी है, प्रॉब्लम हो ही सकता है. तो आई हैव सॉल्व द प्रॉब्लम, नाउ एवरीथिंग इज फाइन. Actually my iPad and my iPhone is having some problems, so I have to I just did one thing, turn off the Wi-Fi, then again turn it on, it got corrected. Okay, I just, okay, so great. Yes Ashwin, I'm sorry, actually I'm sorry that we got disconnected. Okay, yes Ashwin, hello, yes. Just let me I'm giving you 30 seconds, then I'm starting. Okay, 30 seconds I'm giving you, then I'm starting. Okay, how many of you are watching this video? Please tell me. I'm sorry, actually I got disconnected. Okay, because my iPhone and iPad has had some problem, so I don't know what happened. They both of them have the problem at the same moment, like with Wi-Fi, definitely. Okay. I think we are fine right now. Okay, should I start then? Tell me, should I start then? Yes, Bikram, yes, thank you, thanks for waiting, thanks for understanding, all of you. Yeah, sure. So I'm starting. Okay, then I'm just finishing this part. Okay, so now question arises. What happens when this particle and antiparticle, these are coming into contact? Or I can ask you one thing, that whatever you can see around you, what are these? Are all of these objects, like these one, even if you talk about this one, whatever you are seeing around you, whatever you can see, even you are, all these are made of particles or antiparticles? Actually, all these are made of particles. There is no existence of antiparticles around you. So if there is no antiparticles around you, then how can I get antiparticles? How can I say that antiparticles is there? Actually, antiparticles was discovered in scientific laboratory. You can't find antiparticles around you, because if antiparticle is there and you have your particle is there, so particle is making all the matters. Okay, and antiparticle is making all the matter, antimatter. If these two are coming into contact, they will cause destruction. So we know antiparticles are there, antiparticles are present in this universe, but they are far away from the particle section. That means whatever you can see around you, sun, earth, any planets, okay, all this universe, everything are made of particles. They are not made of antiparticles. But scientists generally think that, okay, in this universe, because there is no limit for this universe, okay, so in this universe there are some places where only antiparticles are there, and here there only antiparticles are present. So particles and antiparticles, they are not coming into contact. But if it happens that particles and antiparticles, they are coming into contact, only destruction will happen. Only destruction. Got my point? Great. So now this, I told you, particle is one kind of one class of system. Antiparticle is another class of fundamental particles. Now I am going to give you another kind of fundamental particles. So another class of fundamental particles. Another class of fundamental particles, that is called neutrino. And if you have neutrino, this is your particle, then you have to have antineutrino as well. Okay, antineutrino. Now neutrino is there, antineutrino is there. Now I want to tell you one important point regarding this neutrino and antineutrino. Okay, so how you are getting this neutrino or antineutrino, I will be telling you about everything. So guys, you already know the phenomena radioactivity. So it is your nucleus, it is your orbits. For the time being, understand, these are your orbit. This is your orbit. Okay, this is your nucleus. And you know, radioactivity generally happens from the nucleus, not from orbits. That means from nucleus, alpha, beta and gamma rays generally coming, those rays are coming out, and this alpha ray is actually alpha particles, gamma rays, like you can say gamma rays, it's okay, and beta rays is actually beta particles or stream of beta particles. Okay, it is what? Stream of beta particles, and this we call actually as beta rays. Okay, now the thing is that these beta particle we have to consider to understand this neutrino and antineutrino. We don't need to consider alpha particle or gamma particle or alpha ray or gamma rays. We need to understand beta rays. So you have these beta rays, and beta rays should have two different properties, two different possible properties. In one possibility, your beta ray can be, or beta particle can be higher energetic beta particle, and in another case your beta particle should be lower energetic beta particle. Perfect. Higher energetic beta particle and lower energetic beta particle. These two kinds of beta particle you will be having. Got my point? Now what happens? Suppose these are your beta particles, and all these are your higher energetic beta particles. Okay. Now what happens, as these beta particles are higher energetic, so they generally collide with each other. Whenever this beta particle is colliding, so after collision it generally transfers its energy to these beta particles. Suppose, because one will transfer energy, another will gain some amount of energy. So whenever it is transferring its energy, after transferring this energy, it will come back with recoil energy. Okay, so it will transfer its energy and it will come back with recoil energy, and with that recoil energy it will go to the other particle and again collide. So this is happening for higher energetic beta particle, because higher energetic beta particle has very high amount of energy. So after transferring energy, it does have some amount of recoil energy, or it is gaining some recoil energy, and that energy is sufficient for another collision. But in case of lower energy beta particle, what happens? Whenever this beta particle is lower energetic, so after this collision, it doesn't have that amount of recoil energy to come back and collide with another molecule, another beta particle. So it generally collides. It's good. After collision, suppose it is coming at with its energy, it is coming to that position. It cannot reach to that beta particle and collide. That means for lower energy beta particle, it cannot come back to this level. Okay, it cannot come back and it cannot collide once again with its recoil energy. That means higher energetic beta particle is following conservation of energy, but lowest energetic beta particle, or lower energetic, this lower energetic beta particle does not follow the conservation of energy. Okay, now as this particle is not following the conservation of energy, how is that possible? Because in this universe energy is conserved, this concept, but how is this possible that this lower energetic beta particle is not following conservation of energy? It is not colliding with another particle. If it is not colliding, that means after transferring its energy, it is not colliding with another molecule. That means one time will come when all the collisions will be stopped. That is not possible. Molecule should be energetic, it should transfer its energy, then transfer its energy again, gain some energy, again transfer some energy. After collision, if it doesn't transfer some energy, how is that possible? How this conservation of energy should be satisfied? This higher energy beta particle is satisfying conservation of energy, but lower energetic beta particle cannot satisfy this. But it is not possible, It is not lower energetic beta particle is not satisfying the conservation of energy. But the problem is, if any system is not satisfying the conservation of energy, that system is impossible. But in reality, higher energetic beta particle and lower energetic beta particle both are present. Then why we are missing? We are missing something, right? And the missing thing is this, that whenever this particle, this lower energetic beta particle, remember lower energetic beta particle, not higher energetic beta particle, this lower energetic beta particle is colliding with this another beta particle. At that moment, not only it is having some recoil energy, but also after this collision, some other particles are generating. Those particles are called neutrino and antineutrino. Okay, and these neutrino and antineutrino, these are helping to satisfy the conservation of energy. Now your lowest energy beta particle is also satisfying conservation of energy. So conservation energy will be satisfied by all of the systems. Even you, me, everybody is satisfying the conservation of energy. Conservation of energy. Okay. That is the logic. Got it? So that means these neutrino and antineutrino, these are generating through lowest energy beta particle through this collision. Okay, that's the logic. I hope you understood this. Now let's move forward. So like these kinds of beta particles, these kinds of neutrino, antineutrino, beta particles, I told you this is another class of beta particles. I do have other classes of beta particles as well. Other classes of beta particle. One example I want to give you, that is called mesons. Meson is another class of beta particle. Okay. Second is hyperons. It is another class of beta particles. Remember, all these things are a part of particle physics, not chemistry. But I am giving you a little bit brief idea because this thing is present in your IIT JAM syllabus. And I am telling you, I will be finishing all those parts which are present in your IIT JAM syllabus in great detail. That's why I am teaching these things. Great. Fine. So that's all about this. So now I am going to give you the whole list, the full list of different classes of particles, and along with that I am going to show you that you have electrons, protons, neutrons. These electrons belongs to which class, protons belong to which class, neutron belongs to which class. I want to show you. So just let me share my screen so that I can show you, right? Just let me share my screen. Just 1 second. Just look at this. If you look at this picture, okay, it's the list of whole fundamental particles. Okay, so it is about, these are, the first one is my class, then it is name, symbol, rest mass. Rest mass means whenever the particle is in rest condition, that is called rest mass. What will be the corresponding mass whenever the particle is at rest? And rest mass I will be representing in this multiplied by mass of electron. Okay, so rest mass, that means 0, that means actual rest mass is 0 multiplied by mass of electron. Then like it is electron, you can see this, it is electron. So electron has mass 1 multiplied by mass of electron. So I am just making this thing more simpler, that's why I am putting these values. Okay, so mass of electron will be 1 into mass of electron, like that. I hope you understood this point. And it is about half-life. Half-life means what? The particles or the class of particles, whatever I told you, that these are stable, these particles are stable. That means these particles are stable. They don't show any kind of radioactive disintegration. They don't show any kind of disintegration. But the particles which are having this half-life, they are not stable. That means they are one time will come whenever they will be disintegrating some of their parts as a form of different radiations, and they will disappear, or they will be converting to other particles. Simple. So the particles which are having half-life, they are not stable, and other particles are stable. So now first class is photon. So photon class has a particle that is called photon. Okay, and this is symbol, this rest mass is 0 multiplied by mass of electron, that is 0, and it is stable. That is sunlight. Whatever sunlight you are getting, that sunlight doesn't have, sunlight is what? Stream of photon. You know the sunlight is your sun, okay, and sunlight is the stream of photon, you know this already. Then these are like lepton class of particles. Lepton is another class of particle, and it contains e neutrino, mu neutrino, electron. So electron is a particle that comes to this lepton class, right? And it has mass this, and it is also stable, okay, it will not disintegrate any radiation. Then mu, meson, it is also lepton. Then coming to meson, meson is different kinds of mesons are there, pi mesons or pions, kaons, k mesons or eta mesons, okay, these are mesons and these are their half-lives, okay. Then last coming to baryon. Baryon means, look at this, proton and neutron. Actually these protons and neutrons are the part of baryon, and proton is stable but neutron has half-life. That means neutron generally shows radioactive disintegration, and one time will come whenever neutron will get converted to other particle. Actually what happens, neutron gets converted to proton, and this thing I will be telling you whenever I will be teaching you radioactivity in your IIT JAM syllabus. Fine. So that's all about this thing. Now come back once again. Okay, so now come back once again. Now tell me, did you understood this thing? Did you understand this thing? Did you understand this thing? So that's all about this different classes of fundamental particles, and in the next video, in the next class, we will be talking about generation, how we got the atomic structure, and how we went to the Bohr theory, what is old quantum theory, and how we are moving to the quantum world from the classical world. Why quantum world will be needed, where classical world is, why classical mechanics is getting failed, and why we need to move to the quantum mechanics. That I will be starting in the next video. Fine. So for the time being, bye bye, good night, and this video will be uploading within tomorrow morning. You will be getting this video as uploaded video in the atomic structure section in the corresponding batch. Bye bye, good night. Now I am getting